Today we're going to be talking about section 1.3, which is on solving equations. So, verbal expressions can be translated into algebraic expressions by using the language of algebra. So if we look at example 1 here, it says write an algebraic expression to represent each verbal expression. 2 more than 4 times the cube of a number. So 2 more than 4 times the cube of a number. So, okay, so I'm going to change what I know. So 2 more than, well, more than means plus. 4 times is just multiplication. The cube of a number, so that's going to be like some number to the 3rd power. So all I'm going to do is just go 2 plus 4 times x to the 3rd. So we'll do that. 2 plus 4 x to the 3rd. That's all we have to do is just change it just like that. Letter B. The quotient is division of 5 less than a number and 12. Okay, so anytime I see of, I think of multiplication, okay, or excuse me, of my parentheses. So now I'm looking at 5 less than a number and 12. So the quotient of, then we have to do what's in here. So 5 less than a number, so 5 less than a number, so some number minus 5 would be x minus 5, and 12. So the quotient of x minus 5 and 12. So I'd rewrite it over here. Okay, so quotient is division. So it would be x minus 5 over 12. Okay, so anytime I see of, I always think parentheses. Of parentheses. Okay? Here's a couple guided practice problems you can try now. Now, a mathematical sentence containing 1 or more variables is called an open sentence. And a mathematical sentence stating 2 mathematical expressions is called an equation. Equation means that they're equal on both sides. That's how we get equations. Okay, so example 2, it says write a verbal statement to represent each quotient. Okay, so equals, we always like to say is. Okay, so in this case, I could write letter A a bunch of different ways, but if I read it, it says 6 times x equals 72. So I can write it something similar to that. So I'll just do 6 times a number. That's what our variable is, a number. Okay, 6 times a number is 72. Okay, 6 times a number is 72. Now you'll notice I wrote out 6 in a word and 72 as a number. Okay, in general, anytime you're going to do one of these, you can generally pick to write numbers out that are 10 and less. And that's true in English class as well. Anytime you're writing a paper and you have a number that's between 1 and 10, you should actually write out the word, and 11 and bigger, you can write it as a number. Okay, look at the next one. N plus 15 is 91. Okay, so I can do kind of the same thing. I'll do 15 more than a number is 91. Okay, 15 more than a number is 91. Now you'll notice my order kind of switched here. Okay, remember in addition, it doesn't matter how you go. The commutative property says that it'll be the same adding wise. So here's a couple guided practice problems for you to try to write those in verbal statements as well. Now an open sentence are neither true nor false until the variable has been replaced by a number. Each replacement that results in a true statement is called a solution. Okay, we know the word solution of an open sentence. All right, so here's some properties. Reflexive property is like, your reflection in a mirror. Both ways are equal, right? Okay, so A is equal to A. B plus 12 is equal to B plus 12. It's the same, okay? Symmetric says that if A is equal to B, then B is also equal to A. So the order can change. So if you look in our example, 18 is equal to negative 2n plus 4. Well, also it says then negative 2n plus 4 equals 18. The transitive property, if A is equal to B and B is equal to C, then A has to be equal to C. You'll see an example right there that's using variables. It's true as well. And finally, substitution. If A equals B, then A can be replaced by B at any time. Okay, so you'll see right here, 6 plus 1 times x is 21. Well, 6 plus 1 is equal to 7, so I can just replace that as 7x equals 21. Okay, Let's use these right now to try some problems. Example 3, it says name the property illustrated for each one. Okay, so on letter A, if 3a minus 4 equals b, and b equals a plus 17, then 3a minus 4 is equal to a plus 17. So which property said if something equals b, and b equals something else, then they have to be equal to each other. Well, that's the transitive property. Okay? Transitive property. Alright? Letter B. If 2g minus h is equal to 62, and h is equal to 24, then 2g minus 24 is equal to 62. So all I've done is taken 24 and substituted it in for h. So you can tell that this is the substitution property. Substitution property. There's a guided practice problem for you to try as well. Alright, so some addition and subtraction properties of equality. For any number a, b, and c, if a is equal to b and a plus c equals b plus c, then a minus c is equal to b minus c as well. Okay, so if I add something to both sides of the equals, if I add something to one side of the equal sign, I have to add it to the other. Same with subtraction. If I subtract one thing from the left side, got to do it from the right as well. Multiplication property down here, multiplication division, same sort of deal. If you multiply the left side of your equation, you have to multiply the right side, or if you divide, and vice versa. Okay, so whatever you do to one side of your equation, you have to do to the other, and we use that to solve equations. Okay, so these are just one-step equations, and we've done these before. But letter A says n minus 3.24 is equal to 42.1. So I want to get n by itself. I'm isolating that variable. So I look, and it says it's minus 3.24. So the opposite of subtracting 3.24 is adding. So I just add to both sides. Okay? And so we end up getting n is equal to 45.34. Now it says to check our solution. So what I want you to do now is take your calculator and take 45.34 minus 3.24 and see if you get 42.1. I'm guessing you probably do. Letter B. Okay? Negative 5/8 x is equal to 20. Now I want to get x by itself. So to get rid of multiplying by negative 5/8, we do the opposite, which is dividing by negative 5/8. Okay? Divide by negative 5/8. Divide over here by negative 5/8. Now if you think about it, 20 can be written as a fraction, 20 over 1. And dividing by a fraction is like multiplying by its reciprocal. Okay? Alright, so positive times a negative is negative. 20 times 8 is 160 over 5. And we can reduce that down to negative 32. Also, your calculator would help you out right there as well. Okay, so what you can do now is you can take negative 5/8 times negative 32 and check to see that that's a positive 20. Here's two guided practice problems for you to try now. Alright, so solving a multi-step equation. Now, if I look at this one right here, the first thing I see is numbers outside of my parentheses. And we think back to the second section in chapter 1. We talked about the distributive property, which said that I could give 5 to everything in there. I could give 2 to everything in there, right? So this would be 5 times x plus 5 times 3, okay, plus 2 times 1 minus 2 times x. All of that still equals 14. Now let's combine our like terms and our multiplication. So we get 5x plus 15 plus 2 minus 2x is equal to 14. Combining my like terms, 5x minus 2x is 3x. 15 plus 2 is 17. And that's equal to 14. I can subtract 14 or 17 from both sides, and I'd get 3x is equal to negative 3. Divide by 3. Divide by 3. X equals negative 1. Okay, and I could check my answer by putting negative 1 in for x. Okay, so negative 1 plus 3 is 2. 5 times 2 is 10. Okay, 1 minus negative 1 is 2. 2 times 2 is 4. So 10 plus 4 is 14. You'll see that if I plug -1 in, I will get the correct answer. Here's 2 guided practice problems that you can try as well. Alright, the last example we're going to look at, solving for a variable. We can use our information that we've learned today to solve and isolate a variable in a formula. So it says the formula for an area A of a trapezoid is 1/2 h times b1 plus b2, where h represents the height and b1 and b2 represent the bases. Solve the formula for b2. Okay, so I'm actually going to try and get this all by itself. Okay, so I'm going to work backwards. So I'll rewrite, and it says 1/2 h times b1 plus b2. Alright, so I know before I can get started with anything, if I'm going to solve for b2, I got to move this 1/2 h. Okay, so anytime I'm trying to undo multiplying by 1/2 h, I end up having to divide both sides by the same thing, right? So 1/2, a divided by 1/2 h is going to leave me with, okay, well 1 divided by 1/2 is just 2. I have an a over h. And that's going to be left with b1 plus b2. Now you'll notice I'm not writing it in parentheses. I don't need to any longer because I've gotten rid of what I'm multiplying 1/2 h by. So the parentheses I can just drop off. Okay. Now if I want b2 by itself again, I'd have to undo this adding b1. So I subtract b1 from both sides. Okay. Subtract b1 from both sides. And I end up getting 2a over h minus b1 is equal to b2. Okay, now this is technically the answer, but a lot of times we like to see it written where our isolated variable is on the left, everything else is on the right. So, based on the symmetric property, I can just rewrite it as this. Okay? Symmetric property says that if you write it out one way, it can be written out the same thing and still be correct. So b2 is equal to 2a over h minus b1. Here's a formula, and you can go ahead and solve this surface area of a cylinder formula for its height. Similarly done.